In today's video, I'm going to see if I can revive this old USA-made Watchmakers Lathe motor. On my other YouTube channel, I did an unboxing video of my new Elson watchmaking lathe. What could be in here? Oh, this is a healthy piece of metal. Look at that. You know, when I gave the motor a visual safety check, the cloth wire insulation was a mess. As it sits here now, it's been completely rewired, and all we need to do is fill the oil cups, install the brushes, and then reattach the AC power cord, and we can see if this motor spins up, runs smoothly, and doesn't do anything shocking, which I mean in the most literal sense. To see the lathe motor in action, please follow me on my watchmaking YouTube channel at Watch with Mike. Let's dig in. Let's take off the tag. Before the watch industry was industrialized, a watchmaker's lathe was used to turn metal into parts of watches. First pocket watches and then wristwatches. So there's the original color, not far off. Let's pop out the brushes. I've never used a watchmaking lathe before, and I'm hoping to learn how to make parts like screws, winding stems, and balance wheel staffs, and to repair watch parts like broken pivots. Let's see, will that clear? I guess we'll just take it out that way. So, there's our first look in. The shaft looks okay. Alright, so we'll get this all cleaned up. My goal is to disassemble the motor, inspect and clean the parts, resolve any faulty or hazardous wiring, and get the motor running. This motor is finished in the same black wrinkled paint as the lathe it came with, and I plan to preserve the look and finish as much as I can without repainting. Well, I'll need to sketch that out. So I've got the switch side labeled, and I was able to start getting this to wiggle out. I think the problem is, though, I'm going to run out of leash here. So I need to figure out how to loosen this relief. Can we compress it? Let's see. Well, there we go. A little bit of impulsive deconstruction. Come on. There we go. Gotcha. That might be the slack we need. Insulation could be better. Let's see if we can see what's what using a continuity check. Okay, continuity is beep. good. Nope. Nope. Okay, so that one is correct. All right, and so we have that going to the center post on the right. Okay, so switch down. Okay. Okay. So I think we've got that part figured out. 7/16 socket. Rusty nut. There's a washer in there. All right, now that we have some slack, let's see if we can we tease this out. Easy peasy. The wires are direct feed into the coils. I'm not quite sure how to handle that. So let's go ahead and pull those brush wires. There's a power cable there and a power cable there. So there we go. The switch is freed. We know that wire needs to get snipped. There we are. And now this can come out. And see that bad boy right there? Yeah, that insulation's coming off. Well, that was messy. I'm going to need to do an inline splice here. While we are desoldering the switch, I'll see if I could desolder these little clips. See, can we unwrap them? Oh yeah, the wire's just wrapped around that. It's just paper. We'll desolder, resolder, run some new wires, and we'll clean everything up. Sound like a plan? Sounds like a plan. My first order of business is reattaching the old motor brush clips to some new wire. I purchased a selection of heat shrink tubing that should shrink to 1/3 its size, protecting and insulating my solder joints. My new pencil-type heat gun has a shield attachment that deflects hot air to both sides of the shrink tubing at once. I'm feeling pretty good about that. Let's do it again. We're able to clean up the solder on the switch. So we'll now we just need to clean the muck off of it, and then we can wire everything back up. I'm cleaning the case with mild household products. Simple Green's an environmentally friendly degreaser, which I'm diluting with water. The abrasive nature of the wrinkle finish was making crumbs from my paper towel, so I switched to a cloth rag. I switched cleaning solutions to an all-purpose cleaner applied directly to the surface after testing on a small area to make sure it wasn't removing the paint. We're going to reuse the power cord here, and I got a rubber grommet in here as the pass-through. Here's the motor housing. A little bit of paint loss, but the grease came off just fine. There's a look inside. So we'll get some We'll get some oil on there. Plate cleaned up just fine. This was hard to clean because I didn't want to get too rough. But there was definitely some discoloration and buildup over here. I think it may have been from that bad insulation. We're just going to keep that away from there. Everything got ultrasonicked. Everything got wire brushed. That's the end cap. I don't know why it has that little nipple on it, but it does. See if I could peen that little nipple. I'm marking out holes in this work block that I call Big Ugly to help me hold the coil in a good position so I can replace the damaged lead wires. The wire I chose for this project has a high-temperature silicon insulator and fiberglass jacket over a copper-braided wire core. I'm using 13-gauge wire, which had the same outside diameter as the original vintage wire, but the core was way thicker and stiffer than I needed and made the project more difficult. In retrospect, 16-gauge or even 18-gauge would have been fine and have provided all the current capacity needed. Here I'm opening up the braid on both the new and old wire so I can get a better connection between the two. This is a butane-powered cordless soldering iron that I've had for years. It lacks a temperature control, but makes up for it in portability. I had trimmed some excess solder but left a sharp burr, which had poked through the insulation when it shrunk. After trimming, I added another layer of shrink tubing on top of the first. I bought a variety pack of rubber plugs designed to be trimmed to fit your wires and used as grommets. While the diameter was right, the motor case was thicker than these plugs are made for, so they had to be convinced into place. There we go. I color-coded my wiring diagram and striped the wires to match with Sharpie markers so I'd know what's what when the case was closed and the wire origins were hidden. Got it. The thicker wire was particularly challenging to fit into the case with the proper clearance for the spinning armature, and barely fit through the pass-through holes. We forgot something. Need to put that on the inside of the case. Of course, it's right where the wires are. Okay, we got it in. And I put the lock washer on the inside. It didn't have one before, and if there was ever a place for a lock washer, that was it. We'll find another one for the nut side, but I think we're good. So let's see. Let's see if we still spin clear. Gently. Okay, it sounds good. I think we're good. We're still spinning.
I don't know what these screws do. Perhaps they are mounting screws if the motor's being used in a different application. With all the new wires attached and neatly passed through into the motor base, we can turn attention to wiring the switch.
All right. Switch is going to go here. Okay.
Before wiring the switch, I'm holding the motor hostage long enough for you, my beloved viewer, to click the like button on this video.
All right.
Before attaching the motor wires, the switch is bridged with these two short pieces of wire, leaving the tails long so we can join them.
So that's where we'll strip it to, and that is where we will cut it. All right, there it is with the ends trimmed. What I'm going to do is reuse this existing power cord. So I'll need to feed it through, put a knot in it as strain relief, and then we'll just hook it up here with some wire nuts. I don't know if this cord will remain on this lathe motor. It was soldered on. By having it attached with wire nuts, it gives me some options as far as if I want to replace this. So one of the fun things in diagnosing the wiring is that this switch, which I thought was an on-off switch, is actually a direction switch. It just takes the power and reverses everything, which reverses the motor direction. First thing I want to do is fill these oil cups. Inside the cup there is a wick, and the oil soaks through the wick and then provides oil to the motor shaft. These are not ball bearings, these are just brass bushings, and so the oil that's in these little sponges here, it just provides a steady flow of oil onto the shaft as it rides through the bushings. So let's get these loaded up. Yeah, they're going further down than I thought they would. Whoa, it's starting to backflow with oil. So we're just going to put these in until they're flush. So here's the brushes. And it looks like there's still some life left in the brushes, so we're going to reuse them. So the brushes slide in these little holes, and then they're held in place with these threaded caps. Just do a little blot here. We've got the chrome cap, which friction fits over this end. Home stretch power cord. And so we're going to put our little granny knot back into the cord, and this is just going to act as a little bit of tension relief. I auditioned some wire nuts for the job. Where are they? I lost my nuts. Found my nuts. I'm going to try the smaller ones first. Yeah, that feels like it's biting pretty well. There we go. Tug test. Let's see if we can dress these a little bit more neatly. For the record, I plan to circle back and address these exposed contacts. Gosh, I think this thing is ready for testing. So I have an inline switch. Should we do a countdown? 3, 2, 1. Yes! Wow! Smell the ozone. Let's do it again. Uh-oh. What just happened? It's not going back on. Was that the final flight? What happened? Let's see, is it a brush issue? Sometimes if you massage it. Okay, try again. Yep, okay. So the brushes are somewhat directional after they've run for a while, and sometimes if they're turned sideways, it won't make contact with the armature. Let's see if it starts. There it goes. Okay, let's try reversing it right now. So if you're looking down the shaft, it is turning counterclockwise. Let's try the switch. Does it work? It does. Excellent. I'd love to know more about the motor, the RPM, the power, but we're going to find out not by what's written on a label, but rather by putting it into use and seeing how it works as a lathe motor. So with that, I was being a little superstitious. I didn't want to put the nameplate back on it until I knew that it was running. So I think we have passed that test. Yes, there we go. Now that the nameplate is back on, you can see it simply says Elson lathe motor, model, I always thought that was a model 7, maybe it's a model 1. Volts 110 to 125. AC and DC. If this is AC and DC, that means it's what's called a universal motor. Well, that was fun. Now it's time for me to get this motor mounted up on the lathe for which it was intended. So I'm cleaning that up. We'll get that all back together, and hopefully we'll be able to start making little metal chips and curls and get to the point where we can comfortably make our own parts for our watchmaking hobby. Well, thanks for joining me. I'm Mike. The channel is Mike Fixed It. If you like this kind of content, please give it a thumbs up, consider subscribing, and leave your comments in the place below. Be good, be well, and be safe, and I'll talk to you real soon. Bye-bye.
I fixed it.